Hi everyone. Today we're going to continue to learn about chemistry. What I have in front of me are 5 seemingly similar, almost identical liquids. How can I identify what these are? What are some ways you can think of? Could look at the color. I could maybe smell it. I could, what else? How can I find out what these are? Well, I have this magic liquid here, purple liquid. And what I'm going to do is pour it into each of my test tubes and see, can I tell if there's some kind of a reaction? In my first test tube, I only have air, so I'm just going to pour some in. Started off purple, still purple, nothing happened. Let's try the next one. Again, looks pretty similar, a little bit lighter, but that's because maybe it was a little bit diluted. Let's try the third. Oh, that's funny. Wow. That one turned blue. That doesn't look the same as the first, the second. Let's try the next tube. Well, that one looks a little bit different too. A little bit more magenta. Let's try the next one. Oh, wow, look at that. How pretty is that? Looks pink. And whoa, take a look at that. Didn't even change color. Poured this purple liquid in there. It stayed this kind of very, very light yellow color. Look at my test tubes. All different colors. I'm gonna add a little bit more to my first one, just so that you can compare and see how different they all look. Any idea what happened here? We did something similar a few weeks ago where I had white powders that all changed to a different color. But that was simple, right? We knew that I had added Kool-Aid colors, Kool-Aid powder to each of the cups, and I simply added water. This time I added something else. I told you it was a magic solution, but it's not. This is an indicator solution. Nothing fancy. All it is cabbage juice, red cabbage juice. Now, cabbage will actually change color depending on what it's mixed with, an acid or a base. What I have here, well, this was nothing. This was just water, so really just got diluted. This is baking soda mixed with water, borax mixed with water, white wine vinegar, and bleach. If you would like to try this at home, all you have to do is take 4 cups of water, 2 cabbage leaves, put it in a blender and blend for about a minute, and you have your indicator solution. If you are going to test different liquids in your home, please make sure an adult is present to help you and be very careful. Some substances are very harmful, like the bleach. So I did something that I really shouldn't have. I was trying to bake and I was trying to do a chemistry lab at the same time, which is not a good idea. I had some baking soda, cornstarch, sugar, salt, and flour for my baking project. And I had some diatomaceous earth that I was trying to see if it dissolves in water. And now I have it all confused and I don't know which one's which. But that's okay. We're gonna figure out by doing a series of experiments. What are some ways that we can identify what these substances are? Well, I could look at the color and see what color they are. Here is a closer view of the different substances. Now, while we go through and check for their properties, please make sure to have your recording sheet out and follow along with me. Here is the recording sheet. Now what we're going to do is look at the different substances, A through F, check for color, check for texture, solubility, conductivity, pH, and then the name of the substance. On the second page, we actually have a key. We know all of our substances, what their properties are. So once we do the test, at the very end, we will be able to name the substance. Looking at my substances, let's check for color. A is white. B is white. C is also white. D is white. E is white. And F is also white. Let's go ahead and fill in our sheet. As I write white for all of my substances, I'm going to ask you a question. Is color a good way of identifying a substance? It could be, but it's really not, especially today, because all of our substances are white. Let's move on to texture and see, is it a powder or a crystal? Looking at A, I'm going to feel and touch, and this is definitely a powder, not a crystal. Looks like snow. Looking at B, this is also a powder. Taking a look at C, hard to tell from the camera, but I can tell this is definitely a crystal. Looking at D, it feels like a powder, but not quite like the other ones. This is one where I could use a little bit more help, and with the help of a microscope, I could tell that this is a crystal. Here is substance E, and oh, I can tell it right away. It's an easy one. Can you see the crystals? Definitely a crystal. Looking at F, this looks like piles and piles of snow. And oh yeah, definitely a powder. So far I have 6 white substances. 3 are crystal and 3 are powder. Do I have enough information to identify them? I do not. I have to keep going. Next, we're going to check for solubility. I'm going to add water to each of my substances, mix, and we'll see if the substance dissolves. Is it soluble or is it not soluble? Oh, already I can tell some of these are not going to dissolve. Some feel a lot easier to stir, and others are not. But let's wait and see. Remember, if it is clear and colorless, it is soluble. It's going to dissolve. Let's take a closer look. I have let these sit for some time, and that is definitely not soluble. A is a no. Let's go to B. This one doesn't look like A, but it's cloudy. It's milky. This is also not soluble. Look at C. Whoa, what do you notice there? Totally clear. Not any, there's a few grains left at the bottom, but if I stir it longer, it will dissolve, I'm sure. So C is a yes, it is soluble. Let's go on to D. And D, look at that. Also clear, and it has dissolved. D is also a yes, it is soluble. Let's look at E. Oh, perfectly dissolved. E is a yes. And let's look at F. Oh, that is definitely not soluble. Oh, and I can't even stir. It feels like a solid at the bottom. Feels kind of like, it's not a liquid, it's not a solid. Feels like something I have used before. Reminds me of oobleck. So I'm going to write that in there in my notes. It's definitely not soluble, and it reminds me of oobleck. Have a hint as to what that one is. The next thing we're going to check for is conductivity. Does it conduct electricity? I have a homemade tester where all I've done is I have my 9-volt battery, wires sticking to both parts. I have a motor and my electrodes. Now these electrodes, I'm going to test right now to see how this works. But if you remember from our electricity unit, to have the motor run, we need a complete circuit, closed circuit. Right now my circuit is open. I'm gonna close it and the motor up to show you what happens. Can you hear it? Put it on the table, you probably hear it a little louder. That works. In a minute, what I'm going to do is stick this inside of the liquid without having these two touch, because that would be cheating. I'm going to see if my liquids can conduct electricity. Let's test solution A. So I'm going to put them in, keep them in. My motor is not starting. A is not conductive. let's test my second substance. This is B. I'm going to put my electrodes in. Give it a minute. B is not conductive. Let's try C and test for conductivity. What do you notice? That is definitely very conductive. Test it again. Definitely conductive. C is a yes. D. Definitely conductive too. And let's check for E. This is not conductive. It's a no for E. And let's test for F. Yeah, it is not conductive. Now looking at my chart, the conductivity did help me a little bit. Again, I have 4 no's and 2 yeses. The solubility gave me 3 yeses and 3 no's. But as long as those yeses and no's are in different places, that will be most helpful. Before we go on to the last chart, I want you to notice. I want to see if you notice the powder is not soluble. The powder is not soluble. The crystal is soluble. The crystal is soluble. The crystal is soluble. And the powder is not soluble. Seems like a coincidence. We'll see if it is or not. Let's move on and test for the last property. The last property we are going to check for is the pH. I have pH strips here that are all yellow. And what I'm going to do is take out one strip, dip it in there, wait a few seconds, and compare to the code and see, is it an acid or a base? And actually write down a specific number that correlates with the chart here. Before I start, I wanted you just to look at the pH chart, at the colors and the numbers. You can see right now, these have not been reacted yet. As I look at substance A, I'm going to give it a mix, dip my pH strip inside, give it a tap, and compare. As I compare to my chart, this is somewhere between a 6 and a 7, a little bit closer to 7. And I had looked at my key earlier, there are no 6s, so I'm going to put 7 for the pH of A. Here I have B. Going to get my pH strip ready. Put it in there. Bring it out. And compare. Well, this was definitely darker than 7. You can see the color changing fast. Do you see the greenish tint? Let me move this out of the way. I would say that this is definitely an 8. Let's look at substance C. And put it in there and compare. As I look, this is again somewhere between 6 and a 7, but I think it's closer to the 7. Let's look at substance D. Put it in there. Take it out. Wow, look at that. That one's a really, really dark green. Easy to tell. That's definitely a 9. Let's look at E. And I can see already starting to turn green. This is another 7. And finally, my last one, my F. Give it a mix. And this one is also an 8. Here is my completed chart. Now what I'm going to do is compare it to my key and see if I can figure out what the name of the substance is. This is a good time to pause the video and try to fill in this last column. Let's look at the results and see how I was able to come up with each of these. Well, there were some that stood out. I knew how oobleck was made, and that was made from cornstarch. It wasn't soluble. This one helped, but then as I compared what the cornstarch was, it was a white powder, not conductive and not soluble, with a pH of 8, must be cornstarch. Then I looked and I saw, well, I see a 9 here. The other ones are not 9s. Is there a 9 here? Well, yeah, there is. Let's see if it compares. It's a crystal, it's soluble, it's conductive, and a pH of 9. That must be baking soda. And I use this reasoning for the rest of them. Each one gave a little bit of help. I could not have done this with just one property. I needed the help of all of these properties. That was pretty cool, right? I was able to identify my 6 different substances by using their properties. The properties that we used to identify were color, texture, solubility, conductivity, and pH. Would one of these properties been helpful alone to identify? my substance? No way. Which one was the least helpful? Color, right? They were all white. Didn't help me at all. Which one do you think was the most helpful? There's argument for each one. I like conductivity, and I also like pH. They're all pretty helpful, but we needed the help of all of them to be able to identify what was what. What are some other ways I could have tested? Talked about smell, that would be something. Think about other things that we've done. Reactivity. Maybe test it with vinegar. Maybe there would be a reaction. Which one do you know would react with vinegar? Baking soda, that's easy. We've done that a bunch. Baking soda and vinegar causing a chemical reaction. What about taste? Could I have tasted these substances? No way. I had one very dangerous substance. I had diatomaceous earth. In chemistry, in lab, we never taste because that could be very dangerous. If you were at home and only had sugar and salt, could you do a taste test? Sure. Now what we're going to do is take everything that we've learned today and use it for a follow-up lab next week.